We're now going to create another project, and we're going to learn how to do basic math in the C compiler. I've already created a file with some code in it. It doesn't understand how to do it, so I have to edit it in something like Notepad. So you can see I've typed some information already. So we're going to create a project. So we're going to use the project wizard again. I'm going to do this every time. Next. Browse till we find the correct directory. I'm going to call it math. And we're going to add this file to the project. Okay, we'll make sure that the settings debugger are exactly where we want them to be. Okay. And we want the properties to include line numbers from the last time we've saved. All these guys have saved. Cool. Also close this. All right. So now I have a project. This, in fact, this project is about doing simple math. First thing to note is this line here. It shows you how to make a comment. 2 / lines. Anything you add in here will not be is not code. So any sort of time you want comments, you can put them in here. These are simple operations: addition, subtraction, multiplication, division, and modulo. Spelled modulo wrong. Basic operations that you can do here. The way we write math, just like you would do any sort of algebra operation, sum unknown. Here A equals 5 + 2. All our lines of code have to end in a semicolon. Now, this program isn't right because I'm going to build this and we'll find that we have an error message. Okay, here's the error messages. It says, I don't know what A is, I don't know what B is, I don't know what C is, I don't know what D is, I don't know what E is. When C writes programs, all the information that you write has to be stored in memory. Numbers like the 5 and the 2, it knows how to put in memory. But when you create a variable, A and B and C and D, it doesn't know what you want. So we're going to give them names. We're going to tell how much memory that they need. Now, I've used numbers like 5 and 2. That makes them integers. And so we're going to start off by calling them integers. Int A, comma, B, comma, C, comma, D, comma, E. Again, end with a semicolon. So this just assigns space to all these guys. Now if I build the project, and wait, it's happy. No problems anymore. That's great. As you can see, we can do math, except we don't get to see the math right now. We don't get to see what's happening. So what we need to do is go to the debugger, select the tool, and say we want the MPLAB sim. And we get this new bar created here. And this lets us step through all the information that we have. I can create breakpoints here. And the operation of the project as it runs through the debugger will stop at each point. We use this to debug programs to make sure that the calculations are working out the way we want them to. Now, if I press this arrow, okay, it says the first one couldn't be created, so it went to the next one. So when it's at this point, it knows about this, and I can keep going. And then it repeats. So it lets me step through programs. So currently, we're able to do basic operations, but we can't see the result of the operations. Now in C, there's a function called printf that lets you print out the values of any variables that you've created. The structure involves what's called a literal string between two quote symbols, and we can use %u, 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 and %u. The %u is called a format string for printing out integers, and we can do this. Okay? Always end with a semicolon. Now, printf is not part of the basic C compiler, like the addition and subtraction. So if you're going to use this function, it belongs in a library called standard input output. So at the top of the file, we need to include the file that has the function printf. Notice the chevron brackets on the sides of this. That tells the C compiler that that's part of the C library. Lots and lots of useful functions are included in these library packages that are part of C. We'll have to learn some of the basic ones. Standard input, math.h, and the standard library.h, as well as a few others. Now, unfortunately for us, while this will compile, we're not going to be able to see it. Even what we want to do is go to this. Now, as I mentioned, this printf won't actually work. What we're doing, we're in debugging, we're simulating how our computer chip works. And so if we go to debugger and click on settings, first of all, our processor speed default is 1. We'll set that. And what we want is a window to see where everything is. So we're going to apply that, click OK. This has changed now that there's this SimUart1. So this is as if we're printing. This will be the screen window that we'll see any output. But as I mentioned, we're simulating our computer chip. And the statements we have here are not sufficient to make our chip work. There's nothing here that tells the program what kind of chip we're using or anything like that. So what we have to do is we have to include another file. But this is one that we're giving you. So it's include, and it's called single quotes because it's our file. It's called configure user.h. And it's simply a small library that we wrote for you that says how the pick works. And so this will work once I come over here and add some files. Now these files are in a new directory that you're going to have to create called functions. You download the files from the Moodle site, and in functions you're going to include configure usart.c and the header file that we're using, configure usart.h. Okay, so this is very close to it working, except we have to say how we're communicating. And we say configure usart at 9600 UL comma 1. Okay. So this is something that we've written for you that tells it to communicate with some device like a screen. So you can ignore all this for now, but this is sufficient to make the project work for us. So let's build a project. Okay, and I got a fail. Okay, it says I don't know where this function is. So we have to let it know where it is. You would think because I have it over here it would know, but what we have to do is come down to build options, the project, and look at the include search path, new. We want it to say look at functions. So if it's looking for this file, we want it to look in functions where it is. So we'll apply that, say OK, and now we'll build it. Uh-oh, expression syntax. I got an extra semicolon here. That's one of the nice things about the IDE is it finds spelling mistakes for you. I wish I could say I did that on purpose. So here we are waiting for it to build. It always takes a little while to build, longer than you want. But we're waiting and waiting and waiting. Ah, finally, it's done. Okay, so let's go back to the file. Down here, let's set a breakpoint. And here's the USART window. And we're going to step down to there. And one of the things that you see is it's printed out all of these quantities. 7, 5 plus 2, 3 is B, 5 minus 2, and then D is 5 divided by 2, which strangely is 2, but then we remember we've told them the processor that D is an integer, and so it rounds the 2.5 to the integer value 2. But why don't we have E here? Okay. And %2. That's curious. I'm going to run it again. So what I've done is I've made a small correction here. /n/r says, once you finish printing this line, give me a new line and a return. Sort of like what old typewriters would do. Let's see how that works. Again, the compiling is taking lots and lots of time, more time than we want it to. Ah, finally. So now you can see the values print out correctly, and E, the remainder, is 1. Now, I'm not too happy with the fact that 5 over 2 is rounded down to 2. And the reason for that is I said it was an integer. So let's change that. We don't want it to be an integer. We want it to be a floating point number, a decimal number. In the printf statement, this D over here, if we want to use float, it's %f rather than %u. So let's try that again. Let's rebuild. No error messages. So that small modification seemed to have worked quite nicely. Finally, it's printed, so let's run the function again. And now you see when it does 5 divided by 2, it gives me 2.0000. That's not right. Okay, well, it is right, unfortunately, because when it sees this code, 5 divided by 2, because 5 is an integer and 2 is an integer, it thinks we want this calculation to be an integer. There's two ways to fix that. Here's the simple one. Just put a decimal after the number. And recompile. And wait. Good. All right, so now we come up here, right? And now you see that it rounded to 2.500. So notice the color change too. Integers are green, but this float is a light blue. Okay, great. Let's stop there for right now.